Right, so in this third clip, we're going to take the ethanol molecule again, which, as we said in the previous example, previous situation, has within its spectrum 3 peaks due to the presence of 3 different types of proton in the molecule. Now, what we didn't do was assign any of the peaks to a specific type or specific environment of hydrogen within that molecule and try to build up a little bit more of an analytical picture of what we're actually looking at. Now, the position of the peak is actually key, and the peak is at the peak's position in the x-axis, so along here, is dependent upon the size of the magnetic field that the machine is measuring for each of the individual protons. Now, as we've established, a proton is spinning. It's a positive charge. For example, it's spinning upwards. That generates a magnetic field. It's generated because of a spinning positive charge. Now, around the outside of each of the hydrogens, there is, imagine, a circular sphere of electron charge density. So there are electrons around each of the atoms within the molecule. Yes, there are unevenly distributed, etc., but we're going to get to that. But there are electrons around the outside of the hydrogen. The electrons are negatively charged. Okay, those negatively charged electrons are going to shield the positive nucleus from the outside, the applied magnetic field. And so the amount of electrons which are around a proton has an effect upon the position of the peak in the NMR spectrum. Okay, so how we assign that then is we identify within the molecule the electronegative atoms. Okay, oxygen is the most electronegative atom within that molecule. That is going to be pulling electron charge from the hydrogen towards the oxygen. Okay, just by electronegativity, as you've done in year 12 before. That is going to create a delta minus oxygen, and obviously as a result, a delta positive hydrogen. That is going to withdraw some of the electron charge from around the outside of this hydrogen. That is going to do what's called de-shielding. This hydrogen is going to be de-shielded. Okay, so it's undergoing de-shielding. De-shielding of a proton pushes the peak towards the left-hand side of the spectrum. Okay, goes towards the left-hand side. So the hydrogen attached to the oxygen, which is the most electronegative, it is the most de-shielded proton in that molecule. This corresponds to the left-hand peak in the low-resolution spectrum of ethanol. As a result, the next set of de-shielded protons are probably these ones, which are the ones, again, adjacent to the oxygen. So they are probably responsible for that peak. And as a result, the protons furthest from the electronegative atom are the ones which are not de-shielded. They are going to live towards the right-hand side of the spectrum. Okay, so the position of the peak on the scale, a scale which goes from 0 to 10, but in the kind of inverse manner, goes backwards essentially. It's not a negative scale, it just goes backwards. But on a scale of 0 to 10, the closer you are to the left-hand side, the more de-shielded the proton you are observing is. So for this one, the OH proton is the one furthest to the left. The CH3, furthest from the electronegative atom, is the one on the right.